So, yeah. So, looking at types of questions that you can be faced with, you can be asked to draw type 1, to draw a parabola given an equation. You can be asked to find the equation given the drawing of a parabola. You can also find intersection points x, y simultaneously between two parabolas, and also parabolas and straight lines. So intersection points, find the equation given the drawing, parabola equation, and then there's also the concept of converting using completing the square from y equals ax squared plus bx plus c into the form y equals a, the turning point or vertex form, x minus p squared plus q, where the turning point is pq, or the vertex. All right, so let's jump into the first one. Let's see if we can draw a parabola when we're given the equation. All right, so the questions that we want to see here is, can we draw a parabola y equals to, let's say, negative 2x squared plus 4x plus 3? The best way to draw any graph at any point in time is to always maybe just jump into a table of values. So if you can provide some x values, provide some y values. So let's choose random x values. Let's say negative 3, or let's go bigger, negative 8, negative 4, 0, 4, and 8, and let's keep it up in fours. Let's put that on a calculator. Put it on a calculator, and let's see what you get for that. So I take negative 8, and so negative 8, 2, negative 2, bracket, open the bracket, negative 8. This takes a while because you got to put it in an equation. So it's good to keep the equation on your calculator ready to go for the next one every single time. And then 4 times negative 8 plus 3 comes to negative 157. That's pretty big, right? Negative 4, we can see drawing this is going to be not as simple if the numbers are so big. This is negative 45. And if it's 0, it'll just come to 3. If it's 4, positive 4, you end up with negative 13, and then 8. Automatically, right now, this doesn't look like a good method, right? Because the numbers that we're getting is quite far-fetched, and this is negative 93. So to plot that would be a bit ridiculous. So that's why we have all these different rules now that we can dissect from the parabola. The first thing is we know that the y-intercept can be found, and the y-intercept would be this number over here, which is 0, 3. We've just seen it there. When x is 0, then y will equal 3. That'll be my y-intercept. The next thing is every parabola has a turning point, and it's symmetrical about that turning point. Now, the x value of the turning point is given by minus b over 2a. So that means if a equals negative 2, b equals 4, and c equals 3, if I take minus b over 2a, I can get the x coordinate of the turning point. I'm going to use TP as the turning point, and minus b over 2a, and then some y value we don't know yet. So minus b would be minus 4, my a would be negative 2, and this formula is a standard formula, right? This is a standard x value of my vertex formula. So it'll always be given by minus b over 2a. So there's a is negative 2, b is 4, and I need to get the y value after I found this. I put TP over here to imply the vertex. I could also use V as the vertex. So it'll be negative divided by negative is positive. So this is 1. Okay. Now if I put 1 in my equation, I will get this value over here. All right. So if I put 1 in this equation, it means that I would have to have negative 2 times 1 squared plus 4 times 1 plus 3. What will that get me? So if x equals to 1, I get negative 2 plus 4, which is 2. 2 plus 3 is 5. There we go. So we got a turning point. We got a turning point, which is great. We got a y-intercept. We're starting to build a picture here. We've got a y-intercept. We've got a turning point. Excellent. How do we get x-intercepts? And how do we get x-intercepts from an equation that doesn't factorize? Or does it factorize? That's the question. We use the quadratic formula, right? And the quadratic formula gets me my x-intercepts. But the quadratic formula can also be quite tedious. So if you have a calculator, you can put in your calculator a, b, and c, and it will shoot out 2 values for x immediately. If we have to put this manually, it's going to be negative 4 plus minus the square root of b squared, which is going to be 4 squared, minus 4 times a, which is negative 2 times c, which is 3, all divided by 2 times negative 2. I'm going to simplify this now. It's 4 plus minus. That's 16. That's 8, 24. And that's 40 over negative 4. All right, and that's going to be my two x values over there. So we have a y-intercept, 0, 3. We have a vertex, 1, 5. We have a vertex turning point, 1, 5. And now we've got x-intercepts, 2 of them. That should be enough information to draw it, right? 4 plus root 40 over negative 4. Let's quickly work that one out. So 4 plus root 40 over negative 4. And this one, 4 minus root 40 over negative 4. Okay, let's have a look at that. Calculator, press the fraction button. 4 plus root 40 over negative 4 is negative 2.58 and 0. Keep it in your calculator to save time, and then just change the plus into a minus. Look up to 0.58, 0.58, and 0. Now I have sufficient information. I can draw this. I put all my coordinates. I can sketch this. I can sketch it. Let's say sketch it because it won't be super accurate. So 0, 3, 1, 5. And if I can pass it through all of those points, connect the dots into a parabola, would be good. Now remember the turning point, the vertex is at 1. So the number 1 is where there'll be a line of symmetry. So it's going to be turning at this point. We also know that our graph, by the way, has an a value which is less than 0, meaning that it would be Z-shaped. So it's going to turn like this, something like that, right? And if I did leave it as that. This is my y-intercept. This would be 3. That would be 1. This x value here would be negative 2.58. And this one here would be 0.58. Now, that doesn't look right. It doesn't look right. Can you see that? Because that looks like it should be the other way around. This should be positive 2.58, and this should be negative 0.58. So just double check that, right? If I switch these two around, because 1 is over here, that means that number has to be more than 1. So let's make sure we got our quadratic formula correctly. But yes, this was a negative 4 here. Here we go. That'll be a negative 4, and so I'm going to put a negative 4 in there, and let's recalculate that again. Okay, so I'm going back into my calculator just to make sure I get the x coordinate perfect. 2.58 was right here. It's positive 2.58. And then if I make it obviously the other one would be negative 0.58, which was correct. That would be negative, and there would be positive. There we go. Okay, so in that case, by the way, this would be plus and this would be minus. Now that I have that, I've now drawn and I've done the first thing, which is draw a parabola given an equation. Any equation. And how did I do that? I found the y-intercept, I found the vertex, I found the x-intercepts, and then I connected the dots. Alright, connected the dots. I've got my y and I've got my x like this. And also, there was a formula which was minus b over 2a, which I used to get that. And then I substituted it into the original equation to get that turning point there. And there would be this coordinate here, 1 and 5, by the way, because that will be as high as 5 and 1 to the right. Any questions there? Would you like to try one? All right, let's jump into one. Let's go randomly again. Negative y equals negative 3 x squared minus, let's make it very similar to this one, plus 2x plus 5. Plus 2x plus 5. And we want to draw this. Okay, so let's try this. Try this one. Steps. Number 1, y-intercept. Number 2, minus b over 2a to get the turning point. Number 3, minus b plus minus the square root of b squared minus 4ac over 2a to get the x-intercepts, and then connect the dots. Alright, I'll give you a second to try that. Hi girls, you alright? All right. So the first thing we want to do here is remember that step one, my y-intercept is given by that number because if I make x equal to 0, it'll disappear. So x equal to 0 and 5 is my y-intercept. That's really easy. That's the easiest part, right? Then my turning point or my vertex would be minus b over 2a and some y value which I have to find after I found this one. So I can see a equals negative 3, b equals 2, and c equals 5. So negative 2 over 2 times negative 3 and y would bring this into negative 2 over negative 6 and y, which is the same as 1 over 3. So that's my x value. I'm now going to put that 1 over 3 in there and get my y value. And it's going to become negative 3 times 1 over 3 squared plus 2 times 1 over 3 plus 5, which will help me to get that coordinate there. All right, so calculator out. Make sure we all good. Negative 3 bracket, fraction button 1 over 3, close bracket squared plus 2 times 1 over 3 plus 5. That comes to 5.3 recurring or 16 over 3. So this is the same as 0.3 recurring and 5.3 recurring. We now have that. We have our turning point. We can go to step 3. Step 3, we want to find our x-intercepts. So we're going to go with minus b plus minus the square root of b squared minus 4ac over 2a. Minus 2 is my b value. 2 squared minus 4 times negative 3 times 5 over 2 times negative 3. That's negative 2 plus minus 4 plus, that's 12 plus 5, which is 60. 4 times 3 is 12, 12 times 5 is 60, so 64, which will square root into a nice number 8. That would be negative 2 plus minus 8 over negative 6. So negative 2 plus 8 over negative 6. Negative 2 minus 8 over negative 6. Negative 2 plus 8 is 6. 6 divided by negative 6 is negative 1. Negative 2 minus 8 is negative 10 over 6 would be 5 over 3. Divide by 2, divide by 2, and positive. So that's equal to 5 divided by 3 is 1 and 2/3 or 1.67, let's say, rounded. Now that we have this, we have enough to draw our graph. So let's get it sketching. Grab our axes and let's see if we can get an idea of what this graph would look like. So if I grab the axes, I can see that I start with my y-intercept is 5. So let's go up to 5. 1, 2, 3, 4, 5. I also know that my turning point is at 0.3, positive 0.3. So let's say that was over here. That means 1 would be here. So 0.3 recur. And it would turn at 5.3, which would be slightly above 5. 5.3 recurring. So I know this is going to turn and cut through there. And it's going to turn and cut through there, getting me my two x-intercepts. Negative 1, 1.67. Negative 1, 1.67 over there. And this coordinate is 0.33, 5.33, where the 3 is recurring. That's my vertex, and I've now drawn my parabola, and I'm done. Okay. So that's it. Step one, drawing parabola, quite intense. We have different components in there. The next question now, we want to find the equation given a graph. Before we do that, we're going to convert our equation into using by completing the square. We're going to complete the square. All right, so let's see if we can complete the square. All right, so completing the square. They call it completing the square because you have to create a bracket square. So for example, if I have y equals to x squared minus 6x plus 4, I take my middle value, which is b, and I divide it by 2 and square it. That's my first step. So negative 6 divided by 2 and then I square it. That becomes negative 3 squared, and that becomes 9. And that 9 is a very special number because that number will go between negative 6 and 4. I would plus it first, and I would then minus it afterwards. And so y will become x squared minus 6x plus 9 minus 9 plus 4. Technically, we've added 0. Then I would group the first three terms and factorize it into a perfect square. X minus 3 squared. Square root of 9 goes in there. And then negative 9 plus 4 is negative 5. And so now I've got it in vertex form. Now, immediately from this equation, if I'm sketching it, it's so much more easier because I can see my turning point immediately is 3, negative 5, which means I go 1, 2, 3 to the right, negative 5 down. And that's going to be the turning point. I can also see it's a smiley face. The turning point implies it'll be that. I can also use this to find my x-intercept and my y-intercept. I'll make y equal to 0, for example. I can easily find x. Now, I don't have to use the quadratic formula. So I can square root both sides, and I get plus minus the square root of 5 equals x minus 3. And so 3 plus minus the square root of 5 will equal x. And then my y-intercept is 4. Okay, so it'll be like here somewhere. And it's a smiley face, and it's going to go through 3 plus root 5 and 3 minus root 5. Let's see what that is. 3 plus root 5 comes to 5.23. And 3 minus root 5 comes to 0.76. So that's going to be over here. And this is, by the way, 3. So 5 would be in here somewhere. And so we have this over here. And I've drawn the graph much more quicker. I found the x-intercept faster. I got the y-intercept straight away, and I got the turning point directly once I have it in completing the square form. The biggest step here is to remember that we take b over 2 squared, and we add and subtract it. And then we create a bracket squared after that. Okay, keeping this in mind, and I'm just going to leave this on the page. Let's see if we can complete the square. So try this one. So complete the square for y equals to x squared minus 4x plus 6. Try this one. See if you can do that. So if I had two brackets over here, x minus 3 and x minus 3, that would get me x squared. That would get me minus 3x. And the other outer terms would be minus 3x as well, plus 9. And you can see that becomes x squared minus 6x plus 9. So to go from here to here, we have to be able to factorize it. Now, when you're factorizing this, what you have to remember is square root this, square root the 9, and then put that sign in there every time. So you'll end up with x minus 3, and then don't forget to square it. So a typical example would be, let's say I got x minus 8 squared plus 16. So we put the square root of x squared here, square root of 16 here, and we put that sign in a minus. It becomes x minus 4 squared. And that'll be x minus 4, x minus 4, which is factorization, right? X times x will be x squared, minus 4x is minus 4x is minus 8x plus 16. And so from here to get there, it's just factorization. So for this question, what you're going to end up with is negative 4 over 2 squared. That's your b over 2 squared. It's negative 2 squared, which is 4. And so when you get to your second equation, it'll be plus 4 minus 4 plus 6. And so that would become x minus 2 squared plus 2. And that would be the equation that we want to get to, like that. So it looks like this. We're going to have y equals x squared minus 4x plus 6. B over 2 squared is negative 4 over 2 squared, which is 4. We then say y equals x squared minus 4x plus 4 minus 4 plus 6. And then we put a bracket around it. Now, going into factorization mode, remember we put the square root of x here, x squared, which is x, the square root of 4 here, which is 2, and the same sign there, which is minus squared. And then we take those two, make it into plus 2. And so my turning point becomes 2, 2, like that. Try it again. Try this next question. See if you can try this one. Just to get to that part. Y equals x squared, try minus 8x plus 6. Try this one. See if you can do this one. So yeah, let's have a look at it. So this is going to be negative 8 over 2 squared. It comes to negative 4 squared, which is 16. So y equals x squared minus 8x plus 16 minus 16 plus 6. This will become x minus 4 squared. Minus 16 plus 6 is minus 10. And so the turning point would be 410, negative 10. And what you notice is the opposite sign. And for this one, the same sign. This one here, you can see that's the opposite sign. And this one is the same sign. Shall we try another one? All right. All right, let's go through the first one. So what we do here, we take the negative 10 divided by 2 and square it. That's negative 5 squared, which is 25. And then over there, we make some space. We make sure we put plus 25 first, and then minus 25 plus 50. We group the first three terms, factorize it, x minus 5 squared. Minus 25 plus 50 is 25. And so my turning point will be 5 and 25. Okay, good. And then if I've got 14 over 2 squared, it becomes 7 squared, which is equal to 49. And so y equals to x squared plus 14x plus 49 minus 49 plus 20. Group the first three terms, and it becomes x plus 7 squared. Minus 49 plus 20 is minus 29. And so the turning point would be negative 7, negative 29 for this one. And we're done there. All right, so let's progress down. Let's see where we at. We have converting using completing the square. All good. So now if we want to find the equation, if we're given a drawing, would we be able to do that? Let's start with an example. We're given some kind of graph, and it looks like this. And they tell me that my turning point is negative 3, negative 5, and my y-intercept is negative 1. And they say find the equation for this. So firstly, I'm going to write the turning point form for this particular question. And I can see that that's my P and my Q. So it'll be x minus 3 squared minus 5. And that's x plus 3. Making my turning point that. Now, all I need to do is find the a value here. So I'm going to substitute another point here. And that would be this point over here, which would be 0, negative 1. So 0, negative 1 means that x will be 0 and y will be negative 1. And that'll be negative 1, a times 9 minus 5. That becomes 4. That becomes 9a. We divide by 9 on both sides. And so we get a equals to 4 over 9. So I can put that back in here, and I'm now done. I got my equation. Y equals to 4 over 9, x plus 3 squared minus 5. If they want me to write it in the form y equals ax squared plus bx plus c, then I've got to multiply the brackets out. Multiply, simplify to go from there to there. This particular question, they've given me the turning point, right? So I'm given the turning point, so I would use the form y equals x minus p squared plus q. Step 1 is substitute the turning point in. Step 2, substitute another point, any other point given, and get a. And then step 3, just write the equation down. right, let's try one of this. Yeah. Okay, here's my equation coming through. And my turning point is, let's say, -2, -2. And my y-intercept here is 1, y, x. And you want to find the equation for this parabola. Sen mam nic starą bez. All right, you okay? Let's go back quickly. Yeah, let's go back to the reference. Yeah. All right, let's have a look at it. So what we have here is our turning point. So y equals to a x plus 2. Remember, it's the opposite sign of that. And then squared, then minus 2 there. And then from here, we want to find an a value. So we're going to substitute coordinate 0, 1. And we're going to make y equal to 1, x equal to 0. And so that becomes 4a minus 2. Moving it across becomes 3. And dividing it by 4, a will equal 3 quarters. So my equation will be y equals 3 quarters x plus 2 squared minus 2. Okay. You ready to move on? We try another one. Another one? Sure. Let's try another. No problem. Let's. The next one's going to be a slightly different one. It's going to be sad faced, and it's going to have a turning point over here, which is, let's say, 1 and 5. And it goes all the way till negative 2 here and 4 here. And maybe, yeah, let's make sure. Yeah, this is 3 this way, 3 this way, so that's all good. So you can use one of these points if you need to get the equation. Get a. All right, so for this one here, let's have a look. We're going to go y equals a x minus p squared plus q. My turning point is 1 and 5. And then I substitute any point, this point over here, -2 and 0 to find a. So 0 becomes y, and x becomes -2. And that will be -3 squared, which is 9. And so a equals to -5/9. And so y equals to -5/9 x minus 1 squared plus 5. Okay. If I use the other x-intercept, it should get me the same answer. But let's check why. If I substitute 4 and 0, then my equation will become 0 equals a 4 minus 1 squared plus 5, which will still come to 3 squared, which is 9. So same. So even if you use 4 0 or use -2 0, it will still be the same. You can see this is going to be -3 squared, which is 9. And this one here is 3 squared, which is also 9. Let's try another one. Yeah. -3. Or we could use the concept of the intercept. So let's say this is -1 and this is -3. Then this would be 1 and -2. All right, we're going to find the equation. You're full? Go eat. Eat the chips in it that you made. Go finish it. Go finish it. Okay. What you going to die? Okay, let's go through this one. So y equals to a x minus 1 squared minus 2. That's my p and q. And I now substitute any one of these coordinates in here, so negative 1 and 0. That becomes negative 2 squared, which is 4a. I move that across, becomes 2, and I divide by 4 on both sides, getting me a equals to half. And so y equals to half x minus 1 squared minus 2. Done. All right, how did that go? One over 8. Okay. So if I substitute negative 3 in here, then maybe, then I end up with 0 equals to a negative 3 minus 1 squared minus 2. Hmm. This should become, this is going to change the a value. X equals to 1 and y equals to negative 2 is right. And then if I put negative 3 or negative 1, I should have got the same a value. But this will be negative 4, which is 16. And we get a equals to 1 over 8, which is a different answer. So why would this equation be different to that equation? Have we drawn this correctly? And that's the question. This is 1 unit this way, this is 1 unit this way. That's the turning point. So maybe we got two possible equations. Two possible equations, and they're both right. Because if I substitute each one of those points in there, it will work. If I put negative 1 minus 1 is negative 2 squared. Negative 2 squared is 4. 4 over 8 will be half. Oh, that won't work. That actually won't work. All right, which means that there's something wrong with this. We should have been given one of them and not the other. But that is symmetry. There is symmetry here. Ah, can you see the problem here? There's the biggest problem that you can actually see here. Look carefully. You see that? That's supposed to be the other way around. Can you see? So that would prove that those two are completely wrong. So I'm going to do this again. I'm going to change it into that because that was actually plotted incorrectly. All right. So if you spotted that, well done. So I got my turning point is actually negative 2 and 1. And so y will equal a x plus 2 squared plus 1. And now I can substitute negative 3 and 0. I can also substitute negative 1 and 0, and I should get the same equation. So 0 equals a negative 3 plus 2 squared plus 1 will become negative 3 plus 2 is 1. 1 squared is 1. And so a equals to minus 1. And so the equation is y equals minus 1 x plus 2 squared plus 1. Over here I got 0 equals to negative 3 plus 2, which is this one should be negative 1 plus 2 squared plus 1. And this is going to equal to 1 squared plus 1, right? And don't forget the a here. So a equals to negative 1. And so y equals negative 1 multiplied by x plus 2 squared plus 1. And we get the same, exact same answer for each one. Okay. All right, moral of the story, just make sure you get the coordinates right there. Okay, shall we move on? Okay. So what have we actually done? What have we achieved? We can draw a parabola because we know we can get all the different points using the steps. 1, 2, 3, get a y-intercept, minus b over 2a on a normal day. And we can also, given the parabola, find the equation. We can also complete the square. We know how to complete the square and get the turning point form of it. So what we want to do now is find the intersection points of parabola and straight line. But to do this, we need to be equipped with how to solve simultaneous equations. So I'm going to do a quick example here. Suppose you're given two equations, negative x squared plus 9 and y equals 2x plus 3. And I want to solve for x and y. The first thing I'm going to do is take these two equations and equate them. And so negative x squared plus 9 will equal 2x plus 3. Moving everything to the right hand side becomes x squared plus 2x3 minus 9 is negative 6. And now I've got to solve this. So I can use the quadratic formula, minus b plus minus the square root of b squared minus 4ac over 2a to find my exact x values. So minus 2 plus minus the square root of b squared, which is going to be 2 squared, minus 4 times 1 times minus 6 over 2 times 1. That'll be 4, 24, 28 over 2. Once I found this, I've got to substitute it back into any one of the equations. All right, so let's see what x is. So x can equal, on a calculator, minus 2 plus root 28. Press the fraction button. Plus root 28 over 2. It's 1.65. And minus negative 3.64. Negative 3.64. So I substituted into here, and it will shoot out the correct y value. And so for this one, the y value comes to 2 times 1.65 plus 3, 6.3. That will be a coordinate. And if I substitute negative minus 3.64, it comes to negative 4.28. Negative 4.28. And so those 2 points over there would be my points of intersection for this. Okay, so I'm going to give you an equation. I want you to find the exact points of intersection as well. So equation number 1, y equals to x squared minus 4, and y equals to 2x minus 6. Okay, let's make it 2x minus 2. All right, so find x and y for these two. All right, let's go through this one. So I'm going to equate the two. So I'm going to take x squared minus 4 and make it equal to 2x minus 2. Now I'm going to move everything over and change it from negative to a positive. This is minus 4 plus 2 equals 0. And so that's x squared minus 2x minus 2 equals 0. So I can see a equals 1, b equals minus 2, c equals minus 2. And so minus b would be minus 2 plus minus the square root of b squared, which is minus 2 squared, minus 4 times a, which is 1 times negative 2, which is c, over 2 times a, which is 1, getting me my x coordinates. So it's going to be 2 plus minus the square root of 4 plus 8, which is 12. 4 plus 8, which is 12, over 2. And so let's see what these x values come to on the calculator. And that's 2 plus minus 2 plus the square root of 12 divided by 2 comes to 2.73. And if I change it into minus, it'll come to negative 0.73. And so y will equal 2 times 2.73 minus 2, which is 3.46, getting me my coordinate 2.73 and 3.46. All right, that's 4. And then on this side here, I go y equals to 2 times negative 0.73 minus 2. So 2 times negative 0.73 minus 2 comes to negative 3.46. Negative 3.46. So negative 0.73 and negative 3.46. And those two would be my 2 points of intersection for that B. Okay, let's move on to the next type. The next type we're going to be doing is where we want to solve simultaneously, but we're given two parabolas, y equals negative x squared plus 9 and y equals x squared minus 4. So here we would equate them, bring everything onto one side, or bring the x squareds onto one side. Let's say we bring x squared to the right hand side because it's positive. It will become 2x squared. And then 4 plus 9 would get me 13. Divide by 2 on both sides. Square rooting gets me x equals to plus minus 13 over 2. Put that on a calculator. The square root of 6.5 is 2.55. So x can equal 2.55 or negative 2.55. And so y will equal for this as 2.55 squared minus 4. If you put a plus or a minus, you'll get the same answer. 2.55 squared minus 4 is 2.5. And if I put y equals to negative 2.55 squared minus 4, I get 2.5, because a negative times a negative is going to be a positive. Get me two coordinates, 2.55 and 2.5, negative 2.55 and 2.5 for that. And here we have two parabolas, which are technically cutting through the like that. Okay. This takes us now to the next thing. See if we can solve for x for two parabolas. And if you can, that's good. So let's solve for x and y. Y equals a negative x squared plus 4. And y equals to x squared minus 16. Alrighty, let's have a look. So negative x squared plus 4 equals x squared minus 16, getting me 2x squared on the side and getting me 20 on that side, which gets me 10 square rooted plus minus equals x. And so we put that back into the equation and we get y equals, whether it's negative or positive, it'll still become 10 minus 16, which is going to be negative 6. And so the coordinates will be root 10 and negative 6, or negative root 10 and negative 6. And we can put that on a calculator, the square root of 10, and let's see what it comes to. And that'll come to square root of 10, 3.16. So this will be 3.16 and a negative 6, or negative 3.16 and negative 6. And remember, these two are parabolas which are going to have the same y value, right? They have the exact same y value, like that. Okay, so we've done quadratics in many ways, different parts of it. We have the ability to find the intersection now simultaneously between two parabolas, also parabolas and straight lines. Draw a parabola given an equation, find the equation given the drawing. All right. So to make a note that if we given x-intercepts, we can also use the x-intercept form of a parabola. And that would be in a question that would look like this. So if I have a parabola given to me and they tell me the x-intercepts, but they don't tell me the turning point, right? They want me to find the equation. So this would be going back to finding the equation. So let's say something like this, right? So they tell me that this is negative 1, and they say this is negative uh, 5, all right? And I have a point on this, okay, which is not the turning point, but another point on this, which is, let's say over here, which is negative 2 and negative 4. And they ask me to find the equation for this. If I'm given, so here you can see I'm given the x-intercepts. So I'm going to use the form y equals to a, x minus x1, x minus x2, and this form is for x-intercepts, where I'm going to try and find the equation from. Now I know x1 is equal to negative 5 and x2 is equal to negative 1. So y will equal a times x minus 5, so x plus 5, and x minus 1, which is x plus 1. And then I substitute the other point in. The other point is negative 2 minus 4. So x equals to negative 2 and y equals to negative 4. And I put that in there like that. And so making my y value equal to negative 4 at the same time. So negative 4 equals a, negative 2 plus 5, negative 2 plus 1, x you can see and y. So that's negative 4, a negative 2 plus 5 is 3. Negative 2 plus 1 is negative 1. That's negative 3. Divided on the other side becomes 4 over 3. And so a equals to 4 over 3. And so y equals to 4 over 3 x plus 5 x plus 1. And that's going to be that equation there. And what we can do is we can multiply this equation out and get it into the form of a normal quadratic in the form of ax squared plus bx plus c if we find the products of the brackets by expanding the brackets. And by expanding the brackets, we will get there. Okay. So let's draw another one. Let's say I draw another one that goes like this over here, -1, 4, and it goes through the y-intercept of -3. If I want to find the equation for this, remember x1 equals to -1, x2 equals to 4, y equals a x minus x1, x minus x2. So let's substitute that in there. And then we also, after that, substitute the point 0, -3 to find a for this. Alrighty, so last question here. What you're gonna end up with, let's say I work it out over here. Y equals a x plus 1, x minus 4. And I'm gonna substitute 0 and -3 in. So this is gonna be 0, 0, and then -3. So -3 equals a times 1 times minus 4. Divide by minus 4 coming on both sides comes to 3 over 4. And so a equals 3 over 4. And so therefore y equals to 3 over 4 x plus 1 x minus 4. All done there.